Hello everyone, welcome back. So in the previous video, I have explained how byte pair encoding works using an example and enumerated the steps to create the vocabulary of desired size. Those of you who haven't watched the previous videos to get an understanding of byte pair encoding, please refer to my previous videos and then come back to this video to understand the implementation of it in Python. So in this video, let's implement the byte pair encoding. So the first step would be to take a corpus. Let's say this is the example corpus which has 4 sentences. We need to tokenize each of these. So this is a dummy sample data which can be replaced with any of your chosen data to tokenize. The first step is to create the individual words from the corpus, right? That's what is the byte pair encoding algorithm says, to compute the unique set of words in the corpus, which is to do pre-tokenization. So for doing the pre-tokenization, for that let's use the tokenizer from the GPT itself, which will do the pre-tokenization, because the GPT-2 tokenizer implements byte pair encoding. So we'll be using the same tokenizer and not completely tokenize the text, but just do the pre-tokenization part. So for that we are importing the tokenizer from the transformers library. So from transformers we are importing auto tokenizer, and from auto tokenizer we are importing a GPT-2 tokenizer. Once we have a GPT-2 tokenizer, then what we would be doing is we would be creating a list of unique words and also calculate the frequency, or how many times the unique word has occurred in the corpus. So I have created a dictionary in Python which will hold the keys would be the words, unique words in the corpus, and the values would be the frequency of that word. Okay, so what I am doing is for each text in the corpus, text is like for each sentence in this corpus, I am applying the tokenizer. We are using only the pre-tokenizer. You could see pre-tokenize the string, and we are passing the text here. So what we get from this is we get the words and their offset in the sentence. So this offset is not relevant for us. We are only interested in the unique words for implementing byte pair encoding. So I am skipping this part. So next would be we are extracting the words from the output of the tokenizer. So we have used a list comprehension here. So the output from the tokenizer is a list of tuples, and this tuple has word and its offset in the sentence, right? So we are unwrapping the tuple into the word and offset and only collecting the words. Then for each word in the words, we are adding it to our dictionary. So this dictionary will have the keys of the dictionary would be unique, right? So if the word is not present in the dictionary, it will add the word and set its count to 1. Otherwise it will increment the frequency of it. So finally the word frequency dictionary would look something like this, that this is the word that appeared in this text corpus 3 times. So you could see this has appeared 1, 2, 3 times here. So that's what it is listing. Then ease has appeared 2 times, the has appeared 1 time, hugging has appeared 1 time, and so on and so forth. So all the unique words are listed with their frequency. So one doubt that arises is there is this special character called this G with a dot above. So why we are getting this extra character in our output from this tokenizer is that is because we are using the GPT-2 tokenizer. So what the GPT-2 tokenizer does is it does not split the words by spaces outright. Instead it will encode the space also into the word only. Now you could see that ease is having a space in front of it, right? So it will encode that space, that this ease is not the start of the sentence and it is inside the sentence. So to carry that meaning into the tokens, if any word is preceded by a space, it will append this special character to that word, and we would get this appended to the word. So instead of treating the spaces as separate tokens, what GPT uses is a special prefix, and to indicate that token is preceded by a space, we add this G. That's what this is saying, that this special character represents that there is a space before that word. So now we have got the distinct words and their frequency, which is the first step. Now we need to create a base vocabulary with all the unique characters in that corpus. So we need to calculate the base vocabulary found by all the characters in the corpus. So we have created a list called alphabet, and for each word in the word frequency dictionary, what we are seeing is for each letter in the word, if that letter is already not part of list, we are appending it to the list and getting the unique list of characters. So this will be our base vocabulary, all the unique characters that appeared in our corpus. So before starting the byte pair encoding, let us understand that we need some data structures to implement this algorithm, that to hold the intermediate data, so that we don't increase the time complexity of running this algorithm. The first one is a list, which is vocab. So it will hold all the vocabulary that we have obtained so far in the byte pair encoding. And splits is another dictionary. It holds all the co-occurrences of the items or the vocabulary in the corpus. So it will be helpful that to calculate the number of co-occurrences, we could directly refer to this splits dictionary instead of every time splitting the text. So that's what it is saying. It is needed to count the co-occurring bytes or items in the corpus. And merges is a dictionary to hold the merge rules. So this is what we are learning with the byte pair encoding. We will use this merge rules along with the vocabulary to tokenize any new text. So let us use these data structures and implement the byte pair encoding. So we will first fill this vocab data structure. We already got the unique characters appearing in our corpus, right? So it's stored in the list called alphabet. So let's save it into the another list called vocab. Along with that, let's also add a special token end of the text to the vocabulary. So this special token is used in GPT-2 type model tokenizers to indicate the end of a sentence. So we have populated this vocab data structure. Now let us populate the splits data structure that saves the co-occurrence. So what I am talking is, so how it is saved is, we will have a dictionary which saves all the unique words and how the unique word is split initially. So right now in our vocabulary we only have single characters, right? So if we use those as our tokens and split the words, then this is how they are split. So the co-occurrences would be like T and H is a co-occurrence and H and I is a co-occurrence. That's how it is computed. So if we keep track of the co-occurrences like this, it would be easy to count. So in this step, we are populating the splits dictionary by running a list comprehension, wherein for each word in the unique words dictionary, we are splitting the word and creating a list. So this is split into like the THIS, like that. Next, we need to compute. So we have obtained the unique words and also the vocabulary, base vocabulary. The next step is pick the consecutive pair with highest co-occurring count. So now we need to calculate the co-occurrence count for each of the tokens in our vocabulary and see which one has the highest co-occurrence. So if we compute, we use this function compute pair frequencies and pass this splits data structure, which is a dictionary, to compute the co-occurrence. So this dictionary is very helpful to fasten the count of co-occurrence. So we pass the splits to it and we create another dictionary called pair frequencies. It will save each pair and its frequency. The pair would be the key and the frequency would be the value. So what we are doing, for each word and its corresponding frequency from the word frequencies, we are getting the split of that word from this splits dictionary. Once we have the split, suppose if the length of the split is just 1, suppose that word has only one character, then there is no point of calculating the co-occurrence, so we are continuing. Otherwise, let's take this G tokens. So this is the split that we have here. So inside that split, we are iterating over each combination of tokens and creating a pair out of it. So now here G and T would be a pair, T and O would be a pair. That's what it is. Split of I comma I plus 1. So when I is 0, it would be G and I plus 1 would be T. Similarly T and O. So we are creating a pair and adding it to the dictionary of pair frequencies, and this would return the pair frequencies. So when we run this compute pair frequencies on the splits dictionary, this dictionary, we get all the pairs like TH, HI, IS, GI like that, and its frequency in our corpus. So we are printing only the first 5 pairs here, just for the sake of illustration. So similarly, there would be lot of pairs stored in this pair frequencies. Once we have the pair frequencies, we need to find the pair with the highest frequency. So we are iterating over this pair frequencies dictionary and finding out which pair has the maximum frequency in this step. So GT is the pair with the highest frequency, and that is 7. Once we identify the pair with the highest frequency, the next step would be to merge the most frequent consecutive pair into a single token and add it to the vocabulary, and similarly save the merge rule. For saving the merge rule, we have another data structure, right, that I have explained before. We have saved now that would be created, which is mentioned here, that merges dictionary. So that would be saved into this merges dictionary. So we have created a merges dictionary, and it will save which 2 tokens should be combined and what is the output token, and we are adding that to our vocabulary list of vocabulary. So here we have a function to merge this pair of tokens and update the splits data structure. So for each word in our list of words, for each word we have a split, right, from the splits dictionary. So basically the word frequencies is this dictionary, which is holding all the unique words, and for each word we have a split here. So for each word and for each word for its corresponding split, we will iterate this split and see if we have that co-occurrence of the 2 tokens appearing, and we would merge them into a single token. So that is what is implemented in this merge pair. So we'll get the split as a list. Then if the size of the split is 1, then there is no merging, because we only have a single token. We would continue, and in other cases we would iterate that split, and we would check if in the token at ith index and I plus 1th index are matching with our A and B tokens. If they are matching, then we would update the split that the split would be same before the ith index, and at ith and I plus 1th index they would be merged into a single token A plus B, and from that point, like since I and I plus 1th index is merged, continuing from the I plus 2th index till the end would be the same. So that's how the split is updated, and we would update the split, like splits of word would be the new split, and return the splits data structure. So if we apply on this merge pair, and we are merging GT to the splits, and if we see how this G train is saved, you could see like G and T previously were separate in the splits dictionary. G and T are separate, but now for the G train key the split list is updated to this, that G and T are combined. So now we have all the functions to run this in a loop until we get a desired vocabulary size. Let's say we want a vocabulary size of 50. We would run a while loop until the vocabulary size is not reached. We will get the pair frequencies again. So step 3 and 4 should be running in a loop, right? What is step 3? Step 3 is get the pair frequencies, identify the most frequent pair and merge it, right? So that's what we are doing. In a loop we are getting the pair frequencies and identifying the max frequency and getting the pair with the maximum frequency, that is the best pair. Once we get the best pair, we are updating the splits and also updating the vocabulary. We are updating the vocabulary here, and we are adding that best split rule to the merges. So finally, once we reach the vocabulary size of 50, these are the merge rules that we have learned. G and T should be merged as GT, I and E should be merged as IS, E and R should be merged as ER, and so on. And the vocabulary we have obtained is this. So these are the additional tokens that got added because of the byte pair encoding technique. So you could see these are all subword, like these are all chunks of word. So let's see an example how to tokenize a new text. So we have created a new function called tokenize that would use the previously generated merge rules and the vocabulary and take in a new text like this and tokenize it to get an output like this. So what this function is doing is it takes in the text, which is this, which we have passed, and first it would pre-tokenize it using the GPT pre-tokenizer, and once we get a pre-tokenized text, we will extract the unique words from it, and then we'll create a list of lists where the internal list will hold the current split of each unique word. Okay, so from the pre-tokenized text, we are only like for each word in it, what we are doing is we are splitting it initially like at a character level, and then for each pair comma merge from the merge rules, we apply that rule on each of the internal list, that is on each word, and try to merge the individual characters as much as possible until further merging is not possible. And if there is any token that is still remaining in these words which is not part of our vocabulary, we would replace it with the unknown token, and the internal lists are merged into single string and returned as a list. So the output of that would be this. So I hope you understood the implementation of byte pair encoding. If you have doubt, please refer to this collab notebook. I would attach it in the description, and if you still have doubts, please get back to me in the comments. I would be happy to help. Thank you.